All right, next lesson here, we're going to be looking at linear relationships in different contexts. So starting off, this warm-up tells us this lunch special at a pizza shop is 2 slices of pizza for $5. Express the cost of the pizza as a unit rate, and then we're going to create a table from that. Well, if 2 slices cost us $5, we know that $5 divided by 2 slices gives us $2.50 per slice. So if we wanted to create a table, obviously we know if we buy 0 slices, our cost is going to be 0. Our unit rate, 1 slice is $2.50. 2 slices we know is $5, and then we're increasing by that unit rate. We're going up by $2.50. So 3 slices would be $7.50, and then 4 slices would be $10. So if we wanted to write an equation to express this, remember our unit rate is our slope. So we just have y equals 2.5, $2.50 times x. And this is proportional because we are going through the origin at 0, 0. All right, on our getting started activity here, just going to work on identifying dependent quantities and independent quantities in each example. So the first one, Terrence is purchasing canned vegetables at his local grocery store to donate to the local food pantry. Each can cost 59 cents. So we have an independent and a dependent variable. I'm just going to use I and D. So our independent variable in this case would be the number of cans he purchases. And our dependent variable is going to be his total cost. Often when you're buying or selling something, your dependent variable is going to be that total amount of money, whether it's your total sales, total cost, anything related to that. So for the second one, the amount of electricity used by a light changes as the knob on the dimmer switch is turned. So our independent variable in this case is you're controlling how much you turn that dimmer switch. So the amount the dimmer is turned. And our dependent variable is going to be that amount of electricity used. Okay, third one, Stephanie is selling Girl Scout cookies to raise money for her local troop. For each box of cookies she sells, the troop receives $2. So our independent variable is going to be the number of boxes of cookies she's selling. Again, she has control over that. That's our input value. So the number of boxes sold, I'll put. And then our dependent variable, a lot like I mentioned earlier, we're selling something now, so it's going to be that total amount of money earned. Then 4 asks us, how would each problem situation change if you switch the independent dependent quantities? Would each problem still make sense? Well, depending on the context, it's not always going to make sense. Like, for instance, number 2 with the electricity. It wouldn't make sense to reverse those and say that the brightness of the bulb is going to change based off of, or be able to move that dimmer switch based off how bright the bulb gets. It's not going to make that switch move. Or with number 3, also wouldn't make any sense to say something like the number of boxes are forced to be sold based off an amount of money we're told we're earned. So we can't reverse every situation and make it make perfect sense. Sometimes it works, sometimes it doesn't, but more often than not, it would not. Question 1 would be something that would make sense. Like if the independent quantity was the money spent and the dependent quantity was the number of cans, we could make that make logical sense. But again, not every time is that going to work out where we can make it logically make sense. All right, activity 3.1, choosing independent dependent quantities, more work on that. So it says you can choose different independent dependent quantities to model the same information based on what we know. Once you've determined the independent dependent quantities, you need just 2 points to determine the slope or the unit rate. So Josh took a road trip with his family to visit Yosemite National Park, and some information about the trip is shown. So they gave us total miles, total cost for gas, and then total gallons of gas used. So it says after they arrived, Josh was curious about how many miles per gallon their car got on the road trip. So given this question, what would be the independent dependent quantity? So miles per gallon, our independent quantity in that case would be the number of gallons he uses. And our dependent quantity would be his total cost. Or sorry, total number of miles. Reading the wrong question. Total miles. Good. So independent quantity, again, going back, make sure we understand that. Independent quantity would be his total number of gallons he used. Dependent quantity would be the total number of miles he's traveled. So if we want to write an ordered pair of 2 points to answer the question and explain what each ordered pair means in terms of the problem situation. Well, we know we have a starting point, even though it's not listed in that table, of 0, 0. And we also know that at 80 gallons, his total miles is 2,600. So 80 gallons, independent quantity, total miles, 2,600. So there would be our 2 ordered pairs we could use for that situation. So now if we want to determine the unit rate, we can use our slope formula, y2 minus y1 over x2 minus x1, and plug in the numbers we have. So 2,600 minus 0 over 80 minus 0. Now, in this case, it's just going to end up as 2,600 divided by 80 because our origin, our 0, 0 is our x1, y1. And if we divide that, and draw a little line down here, we've got a little more space, we get 32.5 miles per gallon. So how many miles per gallon did their car get on the road trip? Well, we just answered that, 32.5, which is very good. They have a very good fuel-efficient vehicle. All right, continuing with that, the family wants to know about how many gallons of gas on average they use for each mile of the road trip. So our independent quantity in this case, we're looking at number of miles per gallon. So our independent quantity would be the number of miles driven. And our dependent quantity would be the number of gallons used. So if we wanted to write an ordered pair for this situation, it's going to reverse what we just looked at. So we have 0, 0, and our miles driven, our independent now is our x, so 2,600, and our number of gallons used is 80. So essentially it's going to flip that last slope formula we just did, and we're going to end up with 80 over 2,600. So again, we're just subtracting. If we do y2 minus y1 over x2 minus x1, subtracting 0 isn't going to change it. So we just have 80 divided by 2,600, and we get 0.03. So 0.03 gallons are used per mile in that situation. So the family's average gallons per mile was 0.03. Okay, so in different context, we could be looking at 2 different things. We found that they were driving 32.5 miles per gallon. And then if we reverse that, want to know the gallons they're using per mile, for number 2 here, we ended up with 0.03 gallons per mile. So if the family had flown, would they have traveled 2,100 miles? And they would have spent $3,250 for tickets. So compare the cost per mile for flying and driving and determine the independent, dependent quantities and rates for each. Okay, well in that case, the independent quantity is going to be the number of miles traveled, and our dependent quantity is going to be our total cost. So if we look at flying first, so I'm going to say flying. They told us that our cost, $3,250, divided by the number of miles to fly, which says 2,100. And if we divide that, we are going to get that it's costing them $1.55 per mile. And if we look at driving now, we know that driving was $200 for the gas, and driving was a distance of 2,600 miles. Obviously, flying, you're flying in a straight line. That's why they had less distance flying. And if we divide that, we're going to get, it's costing them 0.08, so only 8 cents per mile. So obviously much cheaper to drive, just going to take them much longer to get there. All right, activity 3.2, determining slope from the context. So we're going to identify independent, dependent quantities, write order pairs of 2 points you can use to answer the question, and we're going to then determine the rate for the situation. So Bella's Pizza Shop charges $4.50 for a small, $7 for a medium, $9 for a large pizza. Toppings cost extra, depending on the size of the pizza ordered. Bruce ordered a large pizza with 3 toppings that cost a total of $12.60. What is his cost per number of toppings? Okay, well, independent, dependent variables first. Independent variable, you can choose the number of toppings. That is going to change our price. So the number of toppings, then our dependent is going to be the total cost again. So if we look at 2 order pairs, we know that a large pizza with 0 toppings is costing $9. So there's 1 point we can start with. And then we also know that he ordered a large pizza with 3 toppings and paid $12.60. So there's our 2 points. We got an x1, y1, x2, y2. We plug that into our slope formula. Y2 minus y1 over x2 minus x1. And if we subtract that, we get 3.6 divided by 3, which divides to be $1.20. So it's costing him $1.20 per topping. Okay, if we look at 2, a maintenance crew is paving a road in a 7-hour shift. After 10 shifts, 1.25 miles of road have been paved. After 45 shifts, 5.625 miles of road have been paved. At what rate is the maintenance crew paving the road in miles per shift? Now, just want to point out, they love to throw in some information that is unneeded here. For instance, we don't need to know that their shifts are 7 hours. That's just an extra number put in the problem to see if we can cause some confusion, because we're looking at miles paved and shifts, not how many hours are in the shift. So our independent variable is the number of shifts, and our dependent variable is the number of miles poured. So we got 2 points again they're giving us. They told us after 10 shifts, they've paved 1.25 miles. And then they've also told us after 45 shifts, they've paved 5.625 miles. So again, we got an x1, y1, x2, y2. So if we plug those numbers in, 5.625 y2 minus y1 over x2 minus x1. I'm going to bring it down here. So if we subtract there, we're going to end up with 4.375 divided by 35. And if we divide that, we get 0.125. So we know that they're paving 0.125 miles per shift. All right, and then the third one, Melanie is baking breakfast rolls for a band camp fundraiser. She bakes 15 dozen breakfast rolls in 3 hours. After 8 hours, she has baked 40 dozen breakfast rolls. At what rate does Melanie bake breakfast rolls? So we got an independent variable here. She can decide how many hours she's going to bake. So that's our independent. So number of hours she's baked. And our dependent is going to be the number of rolls she's baked. So again, 2 points we can figure out from this situation. Hours baked, 3 hours, she has baked 15 dozen breakfast rolls. So remember, hours are independent, so that's going first, even though in that sentence it's kind of written the other way, with 15 dozen rolls in 3 hours. And then at 8 hours, she's baked 40. So again, there's our 2 points. Draw a little line here so I don't get it mixed up with this problem. So if we do y2 minus y1, 40 minus 15 over 8 minus 3. And that is going to give us 25 over 5, which divides to be 5. So she is making 5 rolls rolls per hour. All right, and one more of those, number 4 at the top of the next page. Elise's dog Bull has been put on a diet by his veterinarian. He weighs 149 pounds after 8 weeks on his diet. By week 13, he weighs 134 pounds. So his average weight loss per week is what we're looking at here. So our independent variable, we need to know the number of weeks. Our dependent variable is his weight, or weight loss, you could say. Okay, again, they're giving us 2 points. We know after 8 weeks, he's at 149 pounds. And we know after 13 weeks, he's at 134 pounds. So plugging that in, y2 minus y1 over x2 minus x1. And if we subtract there, we're going to get negative 15 over 5, which gives us negative 3. Now, negative number in this situation makes sense in the context because he's losing weight. So he's losing, the dog is, losing 3 pounds per week. All right, so now we're going to look at solving this problem, number 5. Kathy is working after school to finish assembling the 82 favors needed for a school dance. When she starts at 3:15, she counts the 67 favors that are already assembled. She works until 4:30 p.m. to finish the job. So how many favors can Kathy assemble each minute? Well, at her starting point, so we could say at 0 minutes she's worked, she has made 67 favors. So our independent is the number of minutes. Dependent is the number of favors she's made. And then we also know, so at 4:30, so if we're counting minutes, 3:15 to 4:30, and we go up from 3:15 to 4 would be 45 minutes plus another 30. So that's at 75 minutes into the problem. She has made 82 favors. So if we want to know how many favors she's assembling per minute, we can find our slope, y2 minus y1 over x2 minus x1. And if we subtract there, we're going to get 15 divided by 75. So she's making 0.2 favors per minute. Now, it might be more useful to know how many minutes it's taking her to make one favor. So how many minutes does it take Kathy to assemble one favor? Well, if we think of the ratio here, we know it's making her 0.2 favors in 1 minute. So how long does it take to make one favor in X number of minutes? And if we cross multiply, we're going to get 0.2x equals 1, and then divide by 0.2, and we're going to find that x equals 5. So it takes her 5 minutes per favor. So which rate is more meaningful? It's probably more meaningful to know how many minutes it takes her to make one. So if she knows how many favors she still has left to make, she can multiply that by 5 minutes per favor and know that how much longer it's going to take her to finish. All right, last one we're going to end with number 6 in this lesson. Let's get past number 7. So Eddie rented a moving van to travel across the country. The odometer registered 34,567 miles after he drove for 4 hours. And after 7 hours of driving, the odometer read 34,741 miles. What is Eddie's driving rate miles per hour? So again, our independent quantity first is going to be the number of hours he's driving. And our dependent quantity is going to be the number of miles. So again, 2 points were given. After 4 hours, he's at 34,567. And then after 7 hours, he's at 34,741. So again, y2 minus y1 over x2 minus x1. And if we simplify that, we're going to get 174 over 3, which divides to be 58. So Eddie is driving 58 miles per hour.